Is there's three reasons that we're primarily focusing on it.
You're on video, by the way.
Oh, that's cool. There's three reasons that it's kind of the big focus right now, and the first one is that it's safe. It's been used in Japan as an anti-ulcer drug as well as an anti-rheumatoid arthritis drug. So it hasn't been used here, but we know if it's been used in Japan for medicine, safe compound. The other thing is it's relatively cheap, and it's an efficient heat shock protein 7 inducer. So research has shown that it does induce that heat shock protein, the one that's kind of the big daddy.
Mm-hmm.
So what the entire project here is, I guess, hoping to determine is whether or not this general acetone compound can actually kind of confirm that it does induce heat shock proteins, and whether it can protect against oxidative stress. So we'll have cells, we give them oxidative stress, so we're just going to continuously release toxic compounds into them, and then we'll have cells that aren't being treated, and you see if they actually survive, if they have the same heat shock protein count, all that kind of stuff. And the main way that we are doing this is through a comparative analysis. We're comparing rat cells and naked mole rats.
Okay.
Do you guys know anything about naked mole rats at all?
I just know they're naked and ugly.
They're naked. How long do you think a naked mole rat lives?
How long what?
How long do you think a naked mole rat lives?
I would have no idea.
30 to 40 years.
Really?
Yeah, so that's 8 to 10 times longer than any regular old rat. And it's curious, why does this thing live so much longer? I mean, I'll admit they're kind of ugly. I mean, don't like hate me for that, but they're kind of ugly looking. So they live 30 to 40 years. So I was reading some past literature, I guess, and it was saying that they can actually control their metabolism, so upregulate, downregulate when needed. But what Dr. Hagen wants me to focus on is to kind of see if there is a difference in the heat shock protein response, or how they respond to stress. And so what we're doing is we have rat cells, or mouse cells, I guess, and then naked mole rat cells. And we're just comparing both to see if one responds better than the other to oxidative stress, and if it does it do it by having better heat shock proteins or more heat shock proteins? Just kind of comparing the two. And the idea is to determine whether general acetone is actually a viable drug.
Okay.
I mean, if the compound or the concentration needed to induce heat shock proteins is so high, it's not worthwhile. I can't have you drink a liter of general acetone. It's just not worth it. So that's kind of the basics of the project, kind of where it's headed. And this summer is mostly the comparative analysis portion.
Okay.